I'm just going to set this up. I'm going to go for the two-dimensional collision imperfect. Or I could have gone two-dimensional imperfect collision if that would probably made more sense. This is the word collision, by the way. So if I have a 5 kilogram mass cruising along at 2 meters per second and a 3 kilogram mass going this way at 4 meters per second, and so this is the before and after, 5 kilogram mass shooting off at a 37-degree angle, and the 3 kilogram mass shooting off at some angle theta, and 10% loss in kinetic energy. So that means that my initial energy is bigger than my final energy. So 90% of my initial energy is equal to my final kinetic energy. Let's set up our coordinate system, I hat, j hat. So I have three equations here. I'm going to have momentum in the I direction, momentum in the j direction, and then I'll have my kinetic energy equation. So what I'm going to do is let's set up the three equations, and I'm not going to actually solve it. I'll leave that for your own pleasure. So my I hat equation for momentum, initially, my momentum is, well, 10 minus 12, or negative 2 kilogram meters per second, if you want some units, is equal to afterwards. So I have, if this is traveling at speed c, this would be 5c cosine of 37 degrees minus 3d cosine of theta. My j hat equation, well, initially I don't have any momentum in the j hat direction, and so it is 0 equals, and then I'm looking at the vertical components here. So this is 5c sine of 37 degrees and minus 3d sine of theta. And then I have my kinetic energy equation, which is 0.9 times my initial kinetic energy is equal to my final kinetic energy. So 0.9 times my initial kinetic energy, which is 1/2 times 5 times 2 squared, plus 1/2 times 3 times 4 squared, equals 1/2 times 5 times c squared, plus 1/2 times 3 times d squared. And so we have three equations, three unknowns. Just to highlight them, we have this equation right here. We have this equation right here. And this equation right here. Obviously, we can come up with an actual number here, so we just have c and d, but if you've seen the other videos, you know how much joy there is in solving it. But again, three unknowns, c, d, and theta. That's the two-dimensional imperfect collision, at least setting up the equations.